I think we can start. Welcome to this RISIS Research Seminar. I don't remember the number of the seminar, but it's probably around 30 or something like that. So which shows how this series has developed. Today we are moving on a topic which is on the borderline between technology transfer and higher education studies, and which of course expresses well the ambition of the RISIS project to connect these different data worlds. So we will have seminars by Joanna Wolszczak-Derlacz from the Technical University of Gdansk, who is an expert of higher education studies, efficiency studies in higher education. And she will present a paper on determinants of patenting and co-patenting with company by European University. And I'm glad to welcome also Frietsch from ISI Fraunhofer, one of the brightest experts on patenting and patent data in Europe, who will provide us his comments. You know probably the way these seminars are organized. Joanna will present the paper in about half an hour. Then I'll give the word to Rainer for his comments. Then we will have a round of discussion and an open discussion. You can ask a question directly. We are not so many that this will create problem. You can raise your hand. You can also post questions or comments on the chat. We also appreciate if your connection allows to see your faces, at least for a while. This makes the seminars more human. So I will really welcome that you switch on or your camera as much as it is possible to, in a way, provide a more human feeling to our presenter. All this said, I will give the word to Joanna for your presentation.
Okay, good morning. First of all, I would like to thank you for making possible to give the seminar, and thank you for the wonderful discussant. I hope that this is work in progress. So you can ask question during the presentation. I will share the screen. I will make it okay. Is it all right now? Can you see the full screen?
Yes.
Yes.
Everything is fine.
Okay, so I'm from Gdansk University of Technology from Poland, and the title of the paper is the determinants of European universities patenting and co-patenting with companies. So what is the motivation of the study? So we know that there is so-called fair mission of the universities. So not only teaching and not only researching, but the role of the universities is to contribute to the society. So one measure of this contribution can be patenting or co-patenting with universities. And in one paper that you have here, Yamaguchi, it stated that it's generally difficult for universities and private enterprises to cooperate. Also, but on the other hand, there are some opportunities for exploiting potential transfer from academic research to industry. For example, to provide human capital to industries, or from the industries to obtain some additional funds, external funds. Most studies about the university patenting are related to one country, for example, Germany, and so on. So the task of this, the aim of this analysis is to examine in a synthetic way the determinants of patenting and co-patenting with the companies. To the best of my knowledge, it's one of the first paper that tries to analyze co-patenting, university co-patenting with companies. Previous studies of the university patenting, so we can divide them into a few different, so the few different elements that we're taking into account. So first of all, the links between publication and patenting. So there is a discussion in the literature whether there are the substitute goods or they can go and enhance each other. So there's discussion, and there is a different conclusion stating whether patenting and publication activity, they enhance each other or they are against each other. Then there are studies considering the funding and in structure, and for example, private universities, internal and external funding. Usually it is said, as I said before, that if you patent, usually you get, and especially if you patent with companies, you are able to get some external funds. So the external funds usually enhance the patenting activities. Then there's institution support, law and regulation. For example, some universities create spin-off companies in order to enhance the cooperation between industry, the external environment, and university. Then we have university types, private versus public. Usually it is said that private, they patent less than public universities. And for example, university with and without medical school. And here it is found that universities with medical school, they patent more. The next division is concerning to the research situation and individual motivation. And for example, such variables were taken in account as age of the academic staff, seniority, and position of the academic staff. Regional influence, so whether we have a spin-off between regional, for example, the wealthiness of a given region and the patenting activities of the companies. And there are some papers that take into account many different variables. Okay, so data that I'm using, there are three kinds of data that are merged together. So first of all is this ether data. You all know it, individual characteristic of universities. Then ORREC database, so data on publication comes from it. And then RISIS patent, so from which I obtain data on university patenting and co-patenting with companies. So the three data sources are merged by the ID of the university. Then there is a clinic procedure. So I keep only the universities with the research characteristic. I don't take into account small universities. The threshold is 500. So universities bigger than 500 students. I don't take into account specialized institutions such as theological school, Navy school, and so on. So giving the availability of the data, there is more than 400 universities taken into account from 17 countries over the period of time 2011-2018. Although data is in Ether, we have till 2019, but the data about patenting in these last years, it is not, there are many missing observations and also in Ether. So I decided to do not take into account the last year, so to limit till 2018. Here you see number of higher education across different countries. So altogether, each year between 2011 2018, we have more than 400 universities. The 410 is in 2016. You see how many universities from different countries. So the biggest share is from the Germany. And you see that it's not panel data because some of the universities are present in all of the years. For example, in Ireland, we have all of the years 7 universities, but sometimes there is the 1 or 2 universities for some years are missing. As a robustness, I will also do the panel analysis in which I will keep just the universities that are present all the time in the panel. Here you see some descriptive statistics of the universities, students. So we have big universities, for example, the biggest university. So this is the average value by country and for the whole time period of analysis. For example, big universities in Italy, then average per one university is more than 2,000 students. Then we have Netherlands, also big universities in Spain. On the other hand, we have small universities in Portugal, where the average is almost 8,000 students per university. Then we have the variable students per academic staff. It can be proxy of a teaching load. So idea is that if there are more students per academic staff, the teaching load is higher. So as you can see here in France, this is almost 24. On the other hand, in Czechia, there is only 6.7 students per one academic staff. Then the next variable is non-academic staff to total staff. This is it can be the measure of bureaucracy, although the role of non-academic staff and the quality of academic staff can also differ. So as you can see here, the biggest is in Lithuania, and in the UK, this is the biggest share of the non-academic staff per total staff. Then we have publication per academic staff, which can be a measure of the research activity of the university, and the biggest share are for the Ireland and Italy, maybe surprising. But then, for example, for some, and Netherlands, the biggest is for the Netherlands. Then on the other hand, you have small values, for example, Hungary, 0.29. Then the revenue per academic staff, so we see which are rich universities and which are relatively poor. So as you can see here, the biggest share for the Netherlands. We don't have Switzerland here. It should be no, we have Switzerland. Sorry. So yes, but surprisingly, the biggest is for the Netherlands. Then we have the share of core budget, where the core budget, core revenues are understood as in the ether. So they refer to funding available for the operation of the institution as a whole, which is not earmarked to specific activities and whose internal allocation can be decided fairly freely by institution itself. So this is as it is understood in ether. So as you can see here, there are also some differences in this aspect. And the last variable is share of third-party funding, when the third-party revenues refer to funds for specific activities and institution units. They are the sum of grants from national and international funding agency for research activities. Then here you see the share of joint company university patents. Sorry, chat. Sorry, there was a question. Sorry, I didn't know. I didn't see before. How is the publication per academic staff has been calculated? It is yearly average. Yes, it is yearly average. Okay, this is the mean value, and over the period of time, this is yearly average. Then we have the histogram of the share of joint company university patents in total university patents across countries or years pulled together. So as you can see, for the Netherlands, 16% of all patents are joint patent, 60% of the university patents are patents of together with the companies. On the other hand, you have Litva, Poland, Lithuania, with the very low level of co-company patents. For example, in Poland, it is only 2%. So 2% of all university patent is co-company patents. Then we have the model specification, so quite easy model. On the left-hand side, you have as the dependent variable, you have either patents or share of company patents. Then on the right-hand side, we have the log of students, so the measure of size of the university, year funding, private or public university, student per academic staff, publication per academic staff, non-academic staff to total staff, revenues per academic, share of third party, and share of core budget. And then we have the dummy variable for the years and for the country. And because we are using the specific estimation method with zero inflated negative binomial regression for the patents and zero inflated beta regression for the co-company patents, you see here the distribution. As you can see here, we have the biggest value is 0, so this is the over disperse of the 0, so we cannot use the ordinary estimation method. So here you see the estimation results. Dependent variable is number of university patents, and in the zero inflated binomial regression, the results are divided into two parts. The first part is for the Kant equation, so we have the number of patents, okay, and the second part, which I will be showing in a second, it's for the probability of 0. So first here in this table, you see the Kant equation. So as you can see here, the higher the number of students, higher the number of patents. Younger institutions have higher number of patents. Private institution, lower number of patents. Student per academic staff, higher the number of students per academic staff, lower the number of patents. Publication per academic staff, it's positive correlation, so higher the publication per academic staff, higher the patents. So here you remember that one of the in the literature, some of the studies were in fact interested in this correlation between patenting and publication. So what we found that publication enhance the patenting activities. Non-academic staff per academic staff, so higher the share of non-academic staff, higher the number of patents. Revenues per academic staff, as you can see here, is positive. There are small number, but positive. And for the third party, so higher the share of third party, higher the probability of patenting, and core budget is not statistically significant. Now I will show you the second part of this regression. So this is probability of being 0. So here we compare those universities who patent and which do not patent. So this is on the left hand side we have just a dummy variable 0, 1, and probability of being 0. So as you can see here, bigger universities have lower probability of being 0. So other way around, it is in the same direction than the previous table. Year funding, just for this first regression, we have minus, so it means that younger universities has lower probability of being 0. Private universities, they have higher probability of being 0, so they have higher probability of non-patenting at all. Then we have students per academic staff. This is the universities with higher level of student per academic staff have higher probability of being 0. Publication per academic staff. So as you can see here, the universities with higher publication per academic staff has lower probability of non-patenting. Non-academic staff, the same relation as in the previous in the Kant data, and these revenues, I cannot find any statistical significant correlation here. And the second model is when the dependent variable is the share of co-patents with companies in the total number of university patents. So on the right-hand side, we have the same variables as before. And you see here 7 different specifications depending on the variables that are incorporated in the regression. So as we see here, so now there will be again two parts of the results. First is for the proportion equation, so for the share of the co-patents with companies, and again the second would be the probability of being 0, so no patenting with companies to co-patenting with companies. So from this we see that higher number of students, the size of the university, lower the proportion of equation, proportion of the co-patenting. Year foundation just in these two specifications. So younger universities have lower proportion of the co-patenting. Private universities has lower proportion of co-patenting with companies. Students per academic staff, maybe it's surprising, but it has higher proportion of the co-patenting. Publication per academic staff, here we have negative variable, negative correlations of higher the publication per academic staff, lower the share of co-patenting with companies. And then we jump to the third party. Third party, surprisingly, is negative. So higher the third party, lower the share of co-patents with company in total patents, and core budget is the same. And as I said, the second part of the same estimation of the equation is the probability of being 0. And there are some. So here we have we compare the universities for which the co-patenting with companies is 0, and with when the co-patenting is different than 0, so they patent. So patenting with companies versus non-patenting with companies. So as you can see here, for the students, higher the number of students, bigger the size of the university, lower the probability of being 0. So it's different from the previous regression, previous result. It was when the size was negative for the proportion of equation, and it is also negative for probability of being 0. But just to note that this probability of being 0, it means that the bigger universities has lower probability of non-patenting with companies. Year foundation, the younger universities lower the probability of being 0. Private universities, higher probability of non-patenting with companies. Student per academic staff, so higher than students per academic staff, higher the probability of being 0, so of non-patenting. Publication per academic staff, higher the publication of per academic staff, lower the probability of being 0. And in the previous it was other way around. In the previous table because when we consider the proportion equation, higher the publication per academic staff, lower the proportion. But when we compare just the universities which co-patent with companies, we see that the higher the publication per academic staff, lower the probability of non-patenting with companies. And then we have revenues per academic staff. Again, it's negative, and also it is negative for third-party core budget. In the previous table, it was again different because it was negative, meaning that universities with higher share of third party or core budget, the proportion of co-patents with companies was lower, while when we compare the universities which patent with companies to those we do not patent with companies, as you can see here, there is a negative correlation. Okay, so there are some extension or robustness of the analysis. So regression with all time varying variables lagged and can solve the problem of potential endogeneity. So all variables in the model are in lag. So there are the lag variables. Then the next is estimation for the panel data sets. Each university is reported in all years with the lag number of patents as an additional independent variable. Universities which patent in the past are more likely to patent in the future. When we add the variable, the lag number of patents, we add as the one of the right-hand side variable. And conclusion, big, older, public and richer institution patent more. Teaching load, students per academics, staff impacts negatively patenting. Research orientation, publication per academic staff positively affects patenting activities. Third-party funding is positively correlated with patenting. The higher the stock of patents of a university, the higher its propensity to apply for patents. Proportion of joint patents differences for the two-part model, a different impact of the determinants of patenting or no patenting with companies, and the proportion of joint patents. The bigger, older, more research orientation with a higher proportion of core and third-party budget are more likely to co-patent with companies. Conversely, the higher the number of students per academic staff, the higher the probability of no patenting. But for those universities that already patent with a company, the proportion is higher. Private institutions patent less with a company than public ones. And what are the limitations of the study? So, of course, the sample of university, it can be bigger than 400 universities. And there is no information on the characteristic of patents. So this is IPC codes for different types of the patents from which sector they come, and the quality of patents, for example, forward and backward citation, which are usually expressed in OECD as the quality of patents. So more cited patents are assumed to have to be characterized by the higher quality. Okay, thank you very much. And if you have questions, I'm eager to answer. Okay, thank you.
For this excellent and very solid presentation. I would like to give immediately the word to Rainer for your comments.
Okay, thank you, Joanna, for this really nice paper, and also you made it in 25 minutes to really have the whole paper presented and condensed in your presentation. I have 2 slides, but I now need to see how I do this. I'm not so much into. Here we go.
Share screen on the bottom.
Yeah.
Okay, we see it. Yes.
Okay. So now for me it's a little bit weird, but okay. So in principle, I like the paper really a lot. It's really well written, well structured, and has a solid empirical and conceptual basis. So, but I'm asked to review, so I have now a little bit of criticism, or let's say I would even call it more suggestions, which you could take into account for improvements if you want. So I think that the literature review is really well done, but there is some literature which you didn't touch upon, which is, let's say, the science-industry collaboration in general. You mentioned it a little bit, but you could go deeper in this, especially then also some empirical papers on these collaboration that have been presented in the past. There is another one, and I came to this in your conclusions. You say that obviously patenting and publishing is not necessarily a conflict. You conclude that from your analysis, and there is a broad literature on this, mainly on the individual level, that has been brought up already in the early 2000s. this kind of discussion and then continued. So a little bit this conflict between or co-activities of academic versus applied profiles, I would call it. So those who is patenting preventing from publishing or vice versa. And the core message also there is, no, it's not. These two, let's say, profiles support each other. So this could be also a little bit adding to your, let's say, conclusion section and to your conceptual part. A little bit challenging, what I found is that in reality, co-patents are only roughly about 10% of all patents, because there are usually, be it public or private actors, they usually don't always co-patent or file a patent together, but very often they one files the patent or applies for it, and the other one gets a license, which is then a private contract which we don't see. So the problem is, of course, that with the co-patents, you only have the tip of the iceberg, and we don't know how much of the ice is below the surface. That's a little bit a problem. So at least you should take that into account and discuss it. So there is, of course, licensing, and also the collaboration as such between public and private actors can then have, of course, these different forms. So there is licensing, then there can be a transfer of ownership, which you don't see at a certain stage, where the company gets the patent, which was invented by a university, and then the company files because the university simply doesn't want to pay for it or doesn't want to take the administrative burden and whatsoever. And then we have this what we call academic patents, and this could also a little bit you briefly mentioned it also in your conceptual part, but there's of course a broad discussion on that. So what are the patents that we don't see, but which are invented by people from the universities? And meanwhile, the data should be also in RISIS, in the RISIS patent database, so you could even check for that, and you could take that as a kind of dummy or a additional control variable into your model if you want. You didn't explicitly formulate hypotheses in your conceptual part. You did it implicitly, and I also understand that it was more an explorative approach, trying to identify factors given the variables that you had at hand and see how they had an effect. But at one point or the other, it might be good to have explicit formulated some hypotheses which you then can test. So now to the empirical part. When I read the paper, it wasn't clear, it didn't become clear to me why these 17 countries and what about the others, EU countries, for example, especially Sweden and Denmark would be interesting because they have a strong research system. So why are they missing? And you also mentioned that some countries drop out because of not enough data for certain variables. Yeah, here it would be good also to maybe know more about the country, the representativeness of the universities per country, or of those of dropout. I guess not all French universities do not report any data in certain dimensions. Anyway, then I also was wondering about the multicollinearity problem. You mentioned the endogeneity problem in your panel analysis, but also the question of how are these variables that you take into account really correlated and especially multicorrelated, because some of your significance levels appear or disappear depending on let's say the number of variables you take into your model. So this is also a little bit a sign that there could be something with collinearity. And this brings me then to my third point, which is the parsimonious modeling. So I haven't explicitly seen that, let's say, the variance or the model fit as such. So the question is, what is the individual contribution to that? And wouldn't it be better to drop some of these to have a better model that explains then the data you have, instead of just looking at all the variables, which of course, with your explorative approach is in principle okay, but at the end, presenting a model that best fits the data would be maybe an approach. So then there is, when you look at the relation of the share of co-patents and in the share of industry co-patents in total university co-patents, it is of course not only a question of the university side, but maybe also of the industry side. So in some countries, you simply don't have a lot of companies that patent. For example, in Spain, there are not so many companies that really use patents. The number of patents is low. So whereas in Germany, there is maybe the probability that you could co-patent with a company is higher. I'm not really sure how to take that into account, but at least maybe discuss it somehow or take it into account somehow. What also didn't become clear to me which patent you have used. I don't know if there are patent families including singletons. So if you would have done that, then you would have mixed, of course, different patent regimes. And it might be worth at least checking what happens if you take a homogeneous system, for example, EPO patents only or whatever, because then the idiosyncrasies of the different patent regimes within the 17 countries you're looking at might be at least somehow reduced. And now my final points, the unobserved factors. Are there any unobserved factors? And I assume yes, also given the literature. So first was the question that appeared, are your let's say currency variables, are they in PPP dollars or in nominal or in euro or dollar or whatever? At least are they purchasing power parities or not? Because there are big differences, of course, also within Europe or within the countries that you're looking at. Then my main point here would be the system differences that you have within the countries. So you have some countries that have a university-centered system versus some which have a strong PRO system also in parallel. So what is the role for the overall innovation system, national innovation system of universities as such? So you compare or you assume implicitly that these are all equal for the countries you look at. So maybe a dummy at the country level might be helpful here. And then also these buy-dole versus individual ownership models, which we have in Europe, and this is also very different. So who is, let's say, owning the invention? And then maybe in some cases, the university, when you have the buy-dole act, then the university can file a patent. But if you have an individual ownership model, then the shares of university as an applicant are lower than because the professors file the patents themselves. So it might also be worth to take a dummy variable for that into account. And then the types of or profiles of university, you mentioned it yourself a little bit with the medical schools, but I would even go beyond that. For example, technical universities versus universities with medical schools or without, but also teaching versus research universities. You use the relation of students per researcher or per employee, but there might be other factors that define if a university is a research or a teaching university. I mean, you can cover it with some of your data, but I'm not sure. Maybe it could be worthwhile following also up on this and introducing a dummy here, maybe. And then you mentioned at the end, this is my last point, the IPC classes, which could really be interesting, but I think not. I would say even less, because it's not the structure so much of the university. It's maybe better reflected in the scientific profiles of the university. So if they have medical science, of course, is clear, but also natural science, engineering, and if they have big shares of arts and humanities and social sciences, because then, of course, they have a lower, let's call it, propensity to patent. And that might be also worth taking into account. So these are my comments. Thank you.
Thank you so much. I think these are very important comments. And Joanna, do you want to shortly reply, and then we open for a bigger discussion?
So I would just, I have the request. Can you send me the slides? Okay,
yeah,
thank you. So then, thank you for this.
And maybe, Rainer, if you could stop sharing.
Yeah, I try. How do I do this? Okay, yeah.
Okay, perfect.
I made it.
Okay.
But for me, it would be easier if you share the screen.
I think you don't have to answer all of them now,
Mm-hmm.
because, maybe there are also others, but I can send it to you. But if you want, I can share again, of course.
No, so just a few words from me. So this is the priority patents, okay, from RISIS patent. And you said that it's possible to obtain, I don't remember, on the first slide there was that you think that it is possible to obtain.
The academic patents, you mean?
No. In addition to obtain, can you show the second slide?
Okay.
Sorry for that. You see, on the previous one. Okay. You said that it is possible to get application by companies only, but invented in collaboration with universities. Academic patenting, yes, I'm not sure with the data that I obtained for RISIS patents. You cannot, you don't have such variable like academic patenting, yes, that invented in collaboration with universities. And then
it should be available meanwhile.
Yes.
Since this year, it should be available.
Okay. So I didn't know.
In the RISIS, but of course you didn't have that. But the point is indeed that with the let's say science industry co-applications, you have only a certain part, and there are several other.
Yeah, I understand.
So that you don't see.
So Joanna, you have just to go on RISIS to ask the data on academic patent, which are basically cooked by Rainer and his colleagues at Fraunhofer.
Okay.
And just so I check with my knowledge of this data set is correct. These are patents invented by academic inventors identified from Scopus, but owned by the companies. Whereas
or by
what
other
you
CROs or whoever.
Whereas what you get as from RISIS patent, the database in Paris are patents owned by the university.
So just once again, you said that I can get it from RISIS, but not from RISIS patent, yes, but from.
It should be in RISIS patent now. So
in RISIS patent,
you should have it.
Okay. Okay. So thank you very much. You ask the revenues were calculated based on PPP.
Yeah.
That's it. And thank you for all other comments. And there were priority patents, yes, that were taken into account.
Yeah, PPPs in Ether are in euros, but
yes.
this turns out to be the same.
Yeah, but there are PPP, yes, purchasing power standard, yes.
Yeah, but these are in euros, not in dollars.
Yeah.
Yeah, it doesn't matter.
Is the important thing. Yeah.
Yeah.
Okay.
Joanna, do you want to add something more?
No, from me, thank you, Rainer. And then I can, as I told you, this work in progress, so I can thank you for this comment that I can apply for the data.
Otherwise, before opening to all participants, I have a few comments on my side. Some are technical. So why you use as a size variable the number of students, where anyway, since you are normalizing students, etc., by academic personnel, you must have academic personnel. So my baseline in all studies is if you have the personnel data, why you don't use as a size measure the logged academic staff? Because you need them anyway for normalizing. So it's not, of course, students are more complete. Then a second technical question is about the regression technique. I see perfectly well you use a zero inflated binomial for counts of patents, but the share of patents with companies is a bounded variable between 0 and 1. There may be lots of zeros, but the question, did you test a fractional log it instead? Which is probably simpler to use because zeros, so it's a distribution between 0 and 1, it's a share, so this would be an obvious solution. I have the same comments about collinearity, so which has to be checked. In our experience, collinearity, if you normalize all variables, but one is not a big problem. So I think what you did is proper. You introduce a single size variable and then you have all normalized, but you have to check. But my main comment is exactly why you are not using information on subject mix. We know, and obviously, that patents are highly correlated to the subject profile of institutions, and there are the data in ITER. It's based on undergraduate students, but I can tell you it's we cross-check with PhD students distribution, which is more research. It's very similar. So you have the distribution of students by the field of education and training, and you can test the impact of subject. The few use of patent data we made in ITER shows that it's a very strong influencing factor. So this might change completely your picture in some points. And it's highly correlated to other variables, for example, size or research intensity is higher for the technical schools. So it will change many coefficients. Beyond these technical comments, my main question is, what is surprising to you? Because of course, in a paper, you must have a take home besides the fact that you are doing a comparative study, etc. So for example, I'm not hugely surprised the fact that the counts of patents increases when size increases, for example. So what is surprising, which comes back probably to the hypothesis Rainer mentioned, and which ones are not, in a sense, trivial, like size increases output. These are my comments. But then, so maybe if you want to shortly react, and then we open the floor for.
Okay, thank you for the comment. The size I can check with the academic staff, of course. Yes. About the estimation method, yes, for the proportion of the company patents, I use zero inflated beta regression because again we have excess zeros. Yes, but I can try fractional log it as you can.
Yeah, also because it's a question of underlying mechanism generating distribution. So excess zeros in a set of count data means differently than in a share. So it's
okay. Then I have to check collinearity. To tell you the truth, I didn't check it. And subject mix. So what is your advice? Which data in ITER to use for the subject mix?
So I would use the distribution of ISCET 5-7 students, which is bigger sample, so it's more reliable and better availability. So you have the distribution of students by 10 fields of education and training. And then you can you can do some work. So I would, for example, take just the proportion of students in natural and sciences. So it's I think 2 or 3 fields: natural science, exact natural sciences, and technology. And I would add separately the proportion of students in medicine, health and welfare medicine. Probably with these 2 variables, you have a lot of effects because all the other SSH, of course, if one is high, the other one, because the sum of proportion is 1. So I would add the 2 variables: share of students in natural and scientific domains, and actually you have it already in ITER as an indicator, and share of students in medical science.
You put a dummy out of it. That would be my suggestion, having technical universities versus non-technical. And then, of course, taking the medical school as another dummy.
This is exactly what so I would suggest not to use dummies for that, because you have proportions anyway.
Sorry, Benedetto, can you give me 1 minute? Sorry, there is some urgent thing at my home. Sorry, just 1 minute, yes? Sorry for that.
But Benedetto, why don't you want to do dummies?
Because the distribution is a bit continuous. So if you take the only technical ones, you get Polytechnic of Milan. But already ETH Zurich does not have only technical and natural sciences.
Yeah, not only, but bigger share. So you can have a dummy based on a share, let's say 75% or 70 or whatever.
Since the variable is anyway continuous between 0 and 1, I would test. You can test both.
Because my point would be, and this is also what with the other variables that she used, you get maybe more let's say variance that you need, so you get noise instead of proper information. So if you use a dummy, it could be, let's say, more clear.
Yes, but subject mix data in Ether are basically bimodal. So in the sense, you have a chunk of universities which are generalist, and then you get some fair percent of everything. Then you get a lot of specialized. So in a way, the continuous variable does not behave much too different, but than the dummy. Okay. And you avoid to be arbitrary. So Joanna, the suggestion would be to use these variables for share of students in natural and science and share of students in health and welfare. As Rainer is suggesting, you could test either the continuous variables is bounded between 0 and 1, or dichotomize the variable based on some proportion. I would anyway test the university hospital dummy, which is in Ether, because we have it, and that's a standard dummy. It might impact on patenting, but it's also a control because it impacts on all kind of variables. So at worst, it's just a control. And,
okay, thank you for all suggestions.
Then I would like to open for further questions and comments from the audience. Are there other comments? Otherwise, Rainer, do you want to add something?
I would come back to my question again. Maybe Benedetto, you can also say something on this. Why these 17 countries and not 27 or
I guess it's a stupid problem of data availability. But something I would also advise is to check a yearly availability and to try to play with the variables. For example, in some years, in some countries, we only have academic staff by head counts and not full-time equivalents. But the two are highly correlated. So what I do normally, I run a regression in FTEs against head count with a couple of controls, PhD, legal status, etc. And then I use the imputed value. So there is space for imputing, because I agree some of the countries are a bit problematic. Some might have problematic. Sweden, in the university patent data from Paris, were highly problematic because we could not find their universities. We don't know where.
We either. And the problem is that they seem not to patent.
Yeah, but also in academic patents, you don't find them.
Yeah, not some, but not so much.
Yeah. Which of course would make interesting. I'm surprised that Sweden is missing, because the data quality in Ether for Sweden is, Denmark is a problem country in Ether, but Sweden not. And I see the comment of Nordin, Sweden as professor privilege, but academic patents, you should find them anyway.
We find some, of
okay.
course. But the shares are lower than in other countries.
Yeah.
Of academic patents, or in most other countries, I would say. I mean, but on the other hand, we know that, for example, in France, the share is high, or in Spain, the share is high. Therefore, I really suggest, Joanna, you take that also into account.
And what I suggest, ITER is of course a fantastic data set. I cannot say anything else since, but we know that that's the problem of scattered missings. So what is valuable when you use ITER data is to check why a country is dropping, because sometimes it's for a reason, for one variable missing, and you have to make choices in that respect to maximize the sample. I see a question by Mfoma Fat. I don't know how to pronounce it as well.
Yes, can you hear me?
Yes, sir.
Yeah.
Hi, hi, it's Mpoma Fata. I hope you can hear and see me. This might be a bit of a stupid question, but I wanted to know how you attribute the belonging of a patent. Are you using the applicant, the owner, or the inventor, or a combination of these three attributions of belonging?
So this is applicant.
You use the applicant.
Applicant, yes. Not inventor, but applicant.
Yeah,
That's
but
actually
the academic patent data provided by Rainer are based on the inventor. So
it's based on the inventor. So you're looking at an inventor.
No. It's based on the applicant.
All right. So you're looking
These
at the
are
applicant.
science industry co-applications.
Yeah.
Do you think maybe this might be contributing to why you're not seeing the other countries where an inventor of that country of those countries might be working under the company with its locale, not in Sweden, for instance?
Yeah, it might be. So that's in the academic patent. Yes, as Rainer said, it's innovator. Yes.
Yes.
That's an actually interesting phenomenon, because I've been looking into it as well. When you attribute a patent based on the applicant, because you're looking at the firms as the only information that you can disclose in the public space. So the idea that inventors work for multinationals, which is something I encountered as well, where these countries tend to patent from a centralized IP hub, where you may not always actually rely on the addresses or the country that they put in that in those fields. So do you think that maybe if you added an element of the relationship between the inventors and these applicants, that maybe you might find some curious changes when you look at who is actually inventing under the applicants? Then maybe you start to see that the relationships between inventor and applicant may be more relevant than between the firms themselves and the universities.
So thank you for the comment. Yes, if I get the academic patent data, then I can check this relationship, and maybe I can get some more in-depth study.
It's not to deny that the paper itself is not interesting. It's a very interesting look at finding some mathematical relationships between them, because I think Rainer had covered it as well. There's so many qualitative elements related to the persons behind them versus the firms behind them. And that's why sometimes you see these seemingly incomplete data sets. But thank you so much for your presentation. It was very enlightening.
Thank you. Özgur?
Hi, thank you very much. It's a very interesting presentation. Mine is not a question, but maybe observation. In the regressions, when you add the variables about the budget, the coefficient of the variable regarding the university's public or private becomes insignificant. Maybe third party, I don't know, it should be very different to interpret this, because I think the third party funding means not state budget or
no, third party funding is everything which comes outside of the core budget. is mostly public, but usually it's open also to private institutions.
Okay, because in these two regressions, both of them, when you add the third party and core budget variables to the model, in the full model, the coefficient becomes insignificant for private universities or public universities. Just
I think this is a simple interpretation.
Okay.
Private and public are systematically different in terms of size, in terms of amount of money, etc. The difference between public and private in university in patenting is just explained by these resourcing differences and not by the legal status per se. Now, of course, there is a relationship between legal status and amount of resources, for example. So it's not to say that there are no differences, but it's enough to use structural differences without introducing a public-private distinction per se.
Thank you very much.
And thank you for the comment, because in fact, yes, in one regression we have that when I add the financial variables, the statistical significance of the public-private dummy disappear. So maybe I can also explain it as you explain, yes, in the results. Thank you.
Thank you. Any other comments or questions? There is a technical comment. Maybe Nordin, you could tell us.
Hello, good afternoon, everyone. This is just Joanna for you to check. I don't know if you did this in your analysis, whether you've used an inflation variable in your zero inflated negative binomial model. Because the universities in your data set, are they all patenting, or are some just not active in this field? In the latter case, then it makes sense to use that as a inflated model. Otherwise, if they're all active, then it doesn't make sense, because then the zero is an actual outcome.
Okay, thank you, and thank you for posing at the chat. Yes, I will double check it.
Yeah, I will test anyway also a non-zero inflated model, because as Nordini says, it's not clear in this case whether zero means something different than the number zero. Because if it just means that you are trying to patent and you don't patent, then the fact that there is a lot of zero may be just explained by the variables. So many institutions may be too small, for example, and then it's just a size effect, or because the logic of the ZINB is that you have two different mechanisms between 0 and 1 and 1 and 2. If it's just the same mechanism, a simple model, a binomial might work. And I think this was one comment of Rainer. I'm really of using parsimonious model. If a simpler model works, you can always say in the robustness check, I tried also ZINB and it gives the same result. But the simpler model, especially if differences, as far as I see, especially in the main patent model, the direction of coefficients is more or less significance is more or less the same in the zero part and in the count part. So maybe there is no strong reason to distinguish them.
But there are differences in the proportion, yes? There are differences.
Yeah, but proportion check whether, since it's a bounded variable between 0 and 1, check whether a fractional log would work better. Thank you. Any other comments, Rainer? You have still. I think we had a very nice, interesting discussion on something where things are advancing. Maybe to summarize some points for Joanna, and I think there is a lot of value, but there is a need of focus on something which is not more or less obvious. So finding that larger university patent more, I would say no referee would be so surprised to give points to a paper. I think introducing subject mix will change probably your results fundamentally, because we suspect that subject mix is the main driving part. And I think getting from Fraunhofer through RISIS the data on academic patents and comparing with the patents owned by university might be really something you push, and probably it's the first time somebody uses this data in conjunction with ITER, so there is clear novelty. So these are my comments. Now, so as Alessia says, the call for participation in 2024 series of RISIS Research Seminars is open. So if you have good ideas, please post me an email with the idea, maybe some summary. But we are already setting up the next round of seminars. So I can pre-announce you, it will be posted before Christmas, that the 10th of January, there will be a presentation by my PhD students, Marco Cavallaro, on modeling grant funding markets. So we go in the area of research policy, and the further seminars will be announced soon. And if you feel you have something interesting, please come back to me with a proposal and we will accommodate in the slots. All that said, I want to thank also Alessia for organizing the meeting, and thank you all and wish you a good afternoon.
Okay, I would like to thank you all, and to my discussant especially, and to all, and thank you for all your comments. Okay, it will also, you know, to develop my studies. Thank you very much.
Well, thank you all also, and specifically Joanna for the nice presentation.
Absolutely.
Have a good time.
Thank you. Bye-bye.
Bye-bye.
Bye-bye.